Welcome everyone to the Mold-X3D webinar series. My name is Alex Baker from the Mold-X3D North America office here in Farmington Hills, Michigan. Our agenda today is as follows. We're going to be talking about how the differential temperature effect, how the change in temperature across our part affects warpage, and why we actually want to include a cooling system in the Mold-X3D standard workflow. And we're going to go over cooling system methodology, just a general look at what different cooling systems are out there. We'll then get into various cooling simulation methodologies in Mold-X3D, so both from the modeling side and from the theoretical side. And then I have some case studies to present, followed by a best practice discussion with some conclusions. All right, so let's start things off by looking at differential temperature effect. Now, there's a lot of different effects of that go into our warpage calculation, things like fiber orientation, the differential shrinkage effect, which is pretty much the definition of warpage. You have your stress distribution. There's a lot of different components to our warpage, but the primary one of the one that typically has the biggest effect is what we call the PVT effect, or what is more commonly referred to as the differential temperature effect. PVT stands for pressure, volume, temperature, and that'll make more sense in just a moment. But before I get too deep into this, I want you to envision a flat plaque where the top surface is 10 degrees hotter than the bottom surface. These aren't a significant difference, but enough so that there is some sort of warpage implied by this difference in temperature. And when we're talking about the differential temperature effect, that's exactly what we're talking about, is the difference between the top surface and the bottom surface here. So just kind of intuitively, which way do you think this part is going to warp? Is it going to warp upwards like a smiley face or downwards like a frowny face? You don't have to answer that. It's more of a rhetorical question, but just kind of have that in your head as we start to as I start to explain this PVT effect. Now, when we're talking about polymer PVT, we're actually talking about the PVT graph that you would see in the Material Wizard. And this is an example of a semi-crystalline thermoplastic PVT curve. PVT stands for pressure, volume, temperature, and it explains the relationship between those three components. As such, on this graph, we have the x-axis is temperature, the y-axis is volume, and the different curves here represent different pressures. So quite literally, pressure, volume, temperature, the direct relationship between the three. Now we're talking about a differential temperature effect, so I'm going to isolate out the pressure effect. We're just going to be talking about temperature versus specific volume on the y-axis, and we'll just use this red curve as an example.